Hello friends, welcome to the Vicky Notes tutorial. This tutorial will help you to learn the concept of operating system for GATE, UGC-NET PSU and university exam. Please friends press the like button and subscribe my channel. We have discussed. In a deadlock state, the execution of multiple processes is blocked. Deadlock avoidance strategy involves maintaining a set of data. The data is used to make a decision whether to entertain any new request or not. If entertaining the new request causes the system to move in an unsafe state, then it is discarded. Banker's algorithm. Banker's algorithm is a deadlock avoidance strategy. It is called so because it is used in banking systems to decide whether a loan can be granted or not. Prerequisite. Banker's algorithm requires, whenever a new process is created, it specifies the maximum number of instances of each resource type that it exactly needs. Data structures used to implement Banker's algorithm. Following 4 data structures are used. Available, max, allocation, need. Available. It is a single-dimensional array that specifies the number of instances of each resource type currently available. Example. Available R1 equals K, it means K instances of resource type R1 are currently available. Max. It is a 2-dimensional array that specifies the maximum number of instances of each resource type that a process can request. Example. Max P1 R1 equals K. It means process P1 is allowed to ask for maximum K instances of resource type R1. Allocation. It is a 2-dimensional array that specifies the number of instances of each resource type that has been allocated to the process. Example. Allocation P1 R1 equals K. It means K instances of resource type R1 have been allocated to the process P1. Need. It is a 2-dimensional array that specifies the number of instances of each resource type that a process requires for execution. Example. Need P1 R1 equals K. It means process P1 requires K more instances of resource type R1 for execution. Working. Banker's algorithm is executed whenever any process puts forward the request for allocating the resources. It involves the following steps. Step 1. Banker's algorithm checks whether the request made by the process is valid or not. If the request is invalid, it aborts the request. If the request is valid, it follows step 2. Valid request. A request is considered valid if and only if the number of requested instances of each resource type is less than the need declared by the process in the beginning. Step 2. Banker's algorithm checks if the number of requested instances of each resource type is less than the number of available instances of each type. If the sufficient number of instances are not available, it asks the process to wait longer. If the sufficient number of instances are available, it follows step 3. Step 3. Banker's algorithm makes an assumption that the requested resources have been allocated to the process. Then, it modifies its data structures accordingly and moves from one state to the other state. Available equals available minus request I. Allocation I equals allocation I plus request I. Need I equals need I minus request I. Now, Banker's algorithm follows the safety algorithm to check whether the resulting state it has entered in is a safe state or not. If it is a safe state, then it allocates the requested resources to the process in actual. If it is an unsafe state, then it rollbacks to its previous state and asks the process to wait longer. Safe state. A system is said to be in safe state when all the processes can be executed in some arbitrary sequence with the available number of resources. Thank you so much friends for watching my video lectures.